A cone is an organ on plants in the division Pinophyta that contains the reproductive structures. The familiar woody cone is the female cone, which produces seeds. The male cones, which produce pollen, are usually herbaceous and much less conspicuous even at full maturity. The name cone derives from the fact that the shape in some species resembles a geometric cone. The individual plates of a cone are known as scales. The male cone is structurally similar across all conifers, differing only in small ways from species to species, extending out from a central axis are microsporophylls. Under each microsporophyll is one or several microsporangia. The female cone contains ovules which, when fertilized by pollen, become seeds. The female cone structure varies more markedly between the different conifer families, and is often crucial for the identification of many species of conifers. Female cones of the conifer families, Pinaceae cones. The members of the pine family have cones that are imbricate. These are the archetypal cones. The scales are spirally arranged in Fibonacci number ratios. The female cone has two types of scale: the bracts scales, derived from a modified leaf, and the seed scales, one subtended by each bract scale, derived from a highly modified branchlet. On the upper side base of each seed scale are two ovules that develop into seeds after fertilization by pollen grains. The bract scales develop first, and are conspicuous at the time of pollination. The seed scales develop later to enclose and protect the seeds, with the bract scales often not growing further. The scales open temporarily to receive gametophytes, then close during fertilization and maturation, and then reopen again at maturity to allow the seed to escape. Maturation takes 6 to 8 months from pollination in most Pinaceae genera, but 12 months in cedars and 18 to 24 months in most pines. The cones open either by the seed scales flexing back when they dry out, or by the cones disintegrating with the seed scales falling off. The cones are conic, cylindrical, or ovoid, and small to very large, from 2 to 60 cm long and 1 to 20 cm broad. After ripening, the opening of non-serotinous pine cones is associated with the moisture content. Cones are open when dry and closed when wet. This assures that the small, wind-disseminated seeds will be dispersed during relatively dry weather, and thus, the distance traveled from the parent tree will be enhanced. A pine cone will go through many cycles of opening and closing during its lifespan, even after seed dispersal is complete. This process occurs with older cones while attached to branches and even after the older cones have fallen to the forest floor. The condition of fallen pine cones is a crude indication of the forest floor's moisture content, which is an important indication of wildfire risk. Closed cones indicate damp conditions while open cones indicate the forest floor is dry. As a result of this, pine cones have often been used by people in temperate climates to predict dry and wet weather, usually hanging a harvested pine cone from some string outside to measure the humidity of the air. Archetypal cones. Members of the Archetypal have the bract and seed scales fully fused, and have only one ovule on each scale. The cones are spherical or nearly so, and large to very large, 5 to 30 cm diameter, and mature in 18 months. At maturity, they disintegrate to release the seeds. In Agathis, the seeds are winged and separate readily from the seed scale, but in the other two genera, the seed is wingless and fused to the scale. Podocarpaceae cones. The cones of the Podocarpaceae are similar in function, though not in development, to those of the Taxaceae, being berry-like with the scales highly modified, evolved to attract birds into dispersing the seeds. In most of the genera, 2 to 10 or more scales are fused together into a usually swollen, brightly colored, soft, edible fleshy aril. Usually only 1 or 2 scales at the apex of the cone are fertile, each bearing a single wingless seed, but in Saxygothia several scales may be fertile. The fleshy scale complex is 0.5 to 3 cm long, and the seeds 4 to 10 mm long. In some genera, the scales are minute and not fleshy, but the seed coat develops a fleshy layer instead, the cone having the appearance of 1 to 3 small plums on a central stem. The seeds have a hard coat evolved to resist digestion in the bird's stomach, and are passed in the bird's droppings. Cupressaceae cones. Members of the cypress family differ in that the bract and seed scales are fully fused, with the bract visible as no more than a small lump of spine on the scale. The botanical term galbulus is sometimes used instead of strobilus for members of this family. The female cones have 1 to 20 ovules on each scale. They often have peltate scales, as opposed to the imbricate cones described above, though some have imbricate scales. The cones are usually small, 0.3 to 6 cm long, and often spherical or nearly so, like those of Nootka cypress, while others, such as western red cedar, are narrow. The scales are arranged either spirally or in decussate whorls of 2 or 3, rarely 4. The genera with spiral scale arrangement were often treated in a separate family in the past. In most of the genera, the cones are woody and the seeds have 2 narrow wings, but in 3 genera, the seeds are wingless, and in Juniperus, the cones are fleshy and berry-like. Cyadopeteaceae cones. The cones and seeds of Cyadopetes are similar to those of some Cupressaceae, but larger, 6 to 11 cm long. The scales are imbricate and spirally arranged, and have 5 to 9 ovules on each scale. Taxaceae and Cephalotaxaceae cones. Members of the U family and the closely related Cephalotaxaceae have the most highly modified cones of any conifer. There is only 1 scale in the female cone, with a single poisonous ovule. The scale develops into a soft, brightly colored, sweet, juicy, berry-like aril which partly encloses the deadly seed. The seed alone is poisonous. The whole berry with the seed is eaten by birds, which digest the sugar-rich scale and pass the hard seed undamaged in the droppings, so dispersing the seed far from the parent plant. Cycadaceae cones. Though not included under the conifers, this group of cone-bearing plants retains some types of primitive characteristics. Its leaves unfurl, much like ferns. There are 3 extant families of cycads of about 305 species. It reproduces with large cones, and is related to the other conifers in that regard, but it does not have a woody trunk like most cone-bearing families. Welwitchiaceae cones. Like the cycads, this unique cone-bearing plant is not considered a conifer, but belongs in the order Welwitchiales. Welwitchia mirabilis is often called a living fossil and is the only species in its genus, which is the only genus in its family, which is the only family in its order. The male cones are on male plants, and female cones on female plants. After emergence of the 2 cotyledons, it sets only 2 more leaves. Those 2 leaves then continue to grow longer from the base, much like fingernails. This allows it great drought tolerance, which is likely why it has survived in the desert of Namibia, while all other representatives from its order are now extinct. Location and distribution. For most species found in Australia, male and female cones occur on the same plant. with female usually on the higher branches towards the top of the plant. This distribution is thought to improve chances of cross-fertilization, as pollen is unlikely to be blown vertically upward within the crown of one plant but can drift slowly upward in the wind, blowing from low on one plant to higher on another plant. In some conifers, male cones additionally often grow clustered in large numbers together, while female cones are more often produced singly or in only small clusters. A further characteristic arrangement of pines is that the male cones are located at the base of the branch, while the female at the tip. However, in larches and cedars, both types of cones are always at the tips of short shoots, while both sexes of fir cones are always from side buds, never terminal. There's also some diversity in bearing in Cupressaceae. Some, Cupressus for instance, has little or no differentiation in the positions of male and female cones. Cone crops. Cone crop potential can be predicted in various ways. An early indication of a potential crop can be a period of abnormally hot, dry weather at the time of bud differentiation, particularly if the current and preceding cone crops have been poor. Estimates of cone crop potential can be made by counting female reproductive buds in fall or winter, and an experienced observer can detect the subtle morphological differences and distinguish between reproductive buds and vegetative buds. White spruce seed collection is expensive, and collection from cone caches of red squirrels is probably the cheapest method. The viability of seed from cached cones does not vary during current caching, but viability drops essentially to zero after being in caches for 1 or 2 years. Collection of cones in seed orchards has been facilitated by the counterintuitive technique of topping, and collection of cones from the severed crown tops at 1/3 the cost of collection from untopped trees and without decreasing cone production. Pseudo cones. Norway and Sitka spruce are prone to the formation of pineapple gall pseudocones caused by the woolly aphid, Adelgis abiatus. These are not cones, although they closely resemble them. All the trees are not even conifers, however the mature seed-bearing structures closely resemble cones. Cultural uses of cones. Because of the widespread occurrence, conifer cones have been a traditional part of the arts and crafts of cultures where conifers are common. Examples of their use include seasonal wreaths and decorations, fire starters, bird feeders, toys, etc. An intriguing derivation of the impossible bottle mechanical puzzle takes advantage of the fact that pine cones open and close based on the level of dryness. In constructing the pine cone in the bottle display, a closed, damp cone of suitable size is inserted into a narrow-mouthed bottle and allowed to open upon drying. Cone cows are traditional homemade toys, made by children using material found in nature. The most common design is a spruce pine cone with sticks and matches for legs, which can easily be attached by forcing them between the cone scales. Playing with cone cows often includes building an animal enclosure from sticks. For the most part, cone cows have been displaced by manufactured toys, at least in affluent countries. But the creation of cone cows still enjoys some popularity as an outdoor activity for children. Cone cows are a part of children's culture in Finland, where they are known as kapulima, and Sweden, where they are known as kotkorikodjur. Schools and other institutions teach children how to make cone cows as part of outdoors education on nature and history. In Finland there is a fairground with cone cow sculptures large enough for children to ride on. In Sweden, a video game was released in which the player may build virtual cone cows. Swedish artist Lasse Sabag has created artwork with cone cows, which has been included in an alphabet book and featured on a Swedish postage stamp among other classic toys. Cones are also occasionally used as a charge in heraldic coats of arms. Gallery. Visualization of a Cupressaceae cone by microcomputer tomography.